Hello, welcome to this session on hypothesis testing from statistics. My name is Elias, representing Masori Corporation. In this video, I want to take you through the introduction to hypothesis testing, where we will describe what hypothesis testing is all about. We will also look at the steps involved in conducting a hypothesis testing. And these steps will hold for any type of hypothesis testing that you may wish to conduct. We will look at tests regarding population means, and under this we will split the test into two. One involving one population mean and the other involving two population means. We will move on to testing regarding proportions, as well as variances and standard deviations. The last part of this unit will cover the tests of goodness of fit and independence. Now, to ensure that you follow through easily with this unit, the sessions are split into 8 parts. The first part, which will be the continuation from this same recording, will cover the introduction as well as steps involved in conducting hypothesis testing. Part 2 and Part 3 will look at tests about population means, and specifically in Part 2 and Part 3, we will look at one population mean. So we will describe the tests regarding population means and then move on to one population mean with examples. In Part 4 and 5, we will look at two population means. Again, here we will describe the test and also bring in examples. In Part 6, we will look at tests about proportions. So by proportions here, again, we are looking at population proportions. And then we will move on in Part 7 to looking at tests regarding population variances and standard deviations. Part 8, which will be the concluding session, will look at the tests of goodness of fit and independence. Let's move on to the introduction to hypothesis testing. Now, before we move with this session, we need to note that in the first part, we are looking at introduction as well as the steps involved in hypothesis testing. So what is hypothesis testing? So clearly in this session, we will state that hypothesis testing or statistical hypothesis is an assertion concerning one or more populations. What we are looking at here is we want to look at what statement or what assertions are being made regarding the population or more populations. So we want to see if people are claiming that there is something involved or some situations regarding the population, or they are actually claiming that there is no any particular situation. For us to be able to tell, we need to engage in statistical hypothesis. Therefore, hypothesis is usually stated in terms of the population parameter because we want to infer regarding the population. We want to work with a sample and make inferences over to the population. So in conducting hypothesis testing, we distinguish between two types of hypothesis. The first one being the null hypothesis, which is stated to mean no. So the null comes in to state the non-existence of a relationship, meaning no relationship or no effect or no influence. So when we say state the null hypothesis, we are saying formulate a statement that indicates no effect or no relationship. The second one is alternative hypothesis, which supports the existence of an effect or a relationship. And in this session, we'll use H1 or HA to denote the alternative hypothesis. In other books or maybe sessions, you may have seen the capital A being used or J or any letter being used as a subscript. Our main concern here is that the now must have a 0 and alternative can have any subscript. As we move on, so we're saying based on the information that we get from a sample, an individual or a group of researchers will be able to make a decision between the now hypothesis and the alternative hypothesis. So if you accept the now, if your results are in favor of the now, then you are going against the alternative. And if you reject the now, then your results are in favor of the alternative hypothesis. So formally, we can now define what now hypothesis and alternative hypothesis are. Let's start with the now hypothesis. So the now hypothesis, denoted H0, is a statement asserting no change or no difference or no effect or no relationship. The now is a statement indicating no. So whatever you are trying to check, the now is saying it is not there. No relationship, no effect, no change, no difference. So the now is no. When we talk about the now, we are simply talking about no existence. So it is usually a statement with an equal sign on a population parameter. So you will see later on, as we state our now hypothesis, we will use an equal sign, equal to 0, meaning there is no, it's not significantly equal to 0, no effect. Or if we say equal to another parameter, meaning we're saying no difference. Okay? The alternative hypothesis stated H1 or indicated, denoted by H1, is a statement that might be true instead of the now hypothesis. So if we are going to reject the now, then we are working in favor, or we are presenting in favor of the alternative hypothesis. And this hypothesis is usually indicated or presented with inequality signs on a population parameter. These signs include the greater than, the less than, although they're not equal to sign. And when we are looking at the alternative is simply indicating the existence of a substance or existence of a relationship, existence of the effect, existence of the difference, or existence of the change. When we are stating our alternative hypothesis, we are saying there is a change, or there is a difference, there is an effect, or there is a relationship. So using these hypotheses, we are now able to move on in discussing the steps involved in hypothesis testing. Let's move over to the steps. Step number 1 in hypothesis testing requires you to identify the problem you are testing. In testing the problem, you are identifying what your now hypothesis is, and you are also stating your alternative hypothesis. This is the part where you need to indicate which statement has no effect and which statement has an effect. So state the now hypothesis and state the alternative hypothesis. Once you state your now and you state your alternative, you move on to step number 2, where you are now presenting your test statistic. You know what your now is, you know what your alternative is, then you need to identify which test is appropriate for you to be able to solve that problem. So here, you need to identify the test. It can be the t-test or the z-test. It can be the f-test, the chi-square, the binomial, and so on. There are many tests, but depending on the problem you are presented with, you will be able to identify the appropriate test. So step 2 involves identification of the appropriate test to be used in your hypothesis testing. In step number 3, you need to determine your critical region. So you need to check first whether the test you are conducting is one-sided or a two-sided test. If it is one-sided, then you are focusing on one region. And if it is a two-sided, you are focusing on two regions. So based on the type of problem you are facing, you need to determine your critical region under which you accept or reject your null hypothesis. In step number 4, you need to find your observed value. This is where the calculation of the observed value has to be done. So you need to calculate the observed value of your test statistic. You have identified your test statistic in step number 2. Maybe it was a t or a test, a z or a chi-square or an f test. Whichever you are proposed to use, you now need to calculate the observed value following your test statistic. And here you need to determine if it falls in the determined region. When you calculate that t statistic, the observed value, or you calculate the z observed value, you need to check whether it falls within the region that you identified or determined in step number 3. You need to check if it's a one-sided region, check if this observed value falls within the region or outside the region. Doing this will enable you to accept or reject the null hypothesis. Depending on where your observed value is, you can now make a decision. Okay? So if you are not, if you want, you can use an alternative. Instead of using the z directly and calculate, you may compute your p-value, which is your probability value of accepting or rejecting the null hypothesis. And with this p-value, depending on the level of significance, you will be able to compare the observed p-value and the given level of significance, under which you can accept or reject the null hypothesis. Once you have your p-value or you have your observed value from the test statistic, you can now move on and make your decision in step number 5. Here, you make your decision on whether to reject or to fail to reject the null hypothesis based on what you calculated and your comparison with the critical region. Once you decide on whether, say, you've accepted the null or you have rejected the null hypothesis, you move on to conclusion. So under conclusion here, you conclude based on what decision you have made. If you have rejected the null hypothesis, then you conclude that there is a statistically significant change. If you fail to reject, then you're saying there is no significant change. So thank you very much for watching part 1. If you have questions, please send an email to admin@imasori.com, or you can send a WhatsApp message to the number that is on your screen, or better still, visit us at plot number 10424/10 in Casanova Junction of Chongwe and the Hybrid Road of Great East Road at Hybrid Roundabout. I'll see you in part 2, where I will be presenting the population mean test, and we will look at a population mean. See you in part 2.